Hello, and thanks everyone for joining the webinar today. Today we are going to talk about contactless monitoring of water level in rivers using narrow beam radar instruments. My name is Nik Šaorlić and I'm co-founder of Geolux, which is a company that researches, develops and manufactures radar sensors and instruments for use in environmental monitoring. The radar level sensors are instruments that are installed above the water surface, which use the radar principle to measure the distance between the sensor and sorry, it seems we have some small technical problems. Okay. Mogu vidjeti. Hello, and thank you for joining the webinar today about contactless monitoring of water level in rivers using narrow beam radar instruments. My name is Nik Šaorlić, and I'm co-founder of Geolux, which is a company that researches, develops, and manufactures radar-based instruments for use in environmental monitoring. Radar level sensors are instruments that are installed above the water surface, and they measure the distance between the instrument and the water level using radar principle. These instruments are contactless, so they are not in contact with the water, which makes installation very easy and maintenance is simple. There are two general types of radar-based level sensors. Pulse radars use an older technology, and frequency modulated radars, they use more advanced technology, which enables higher accuracy and lower power consumption. In the few pictures, you can see that these types of level sensors are easily installed above the water. You can use some existing structures, such as a pedestrian bridge on an image on the left, or you can use another structure which is already installed over the water, such as a pipe, which can be seen on an image on the right. So when selecting a site for installation, it is good to see if there is already some existing structure that can be used to mount the instruments. The instruments themselves are small and they are not heavy, so this structure does not need support big weight for the installation. However, there are some situations where there is no existing structure over the river. Like in this photo, we had to install an arm that extends over the water, and this arm holds the radar sensor on the end of the arm. On another picture, you can see a different type of arm, which is also installed to extend over the river. One thing which is important when using these types of arms or holding structures is to ensure that there is no vibration or to minimize the vibration to the instrument, because if this arm vibrates, the instrument will incorrectly measure the distance between the instrument and the water. On this photo, you can also see another type of installation where we installed the instrument just beneath the ceiling of a covered channel. So there is a channel for the sewage water, it has a ceiling, and we have installed the sensor just beneath the ceiling. So again, as I said, the sensor needs to be installed above the water surface. In general, the installation is easy because you do not need to get inside the water to place the sensor for level measurement. In some cases, this is extremely good because if you need to put a sensor during some flooding event when the water is very high and it is dangerous to get inside the water, you can still place the sensor above the water and immediately start measuring water level. Sometimes there are some structures above the water, like bridges, that you can use, or sometimes you need to build your own structure, such as an arm to hold the instrument. There are several important things to know about radar levels, which I'm going to discuss now. First thing is the radar beam width. Different radars or different models of radar have different beam width. There are wider radars and radars with very narrow beam width. The wider the beam, more area on the surface of the water is covered by the radar. The radar typically measures the distance to the average height of the water within the area inside the radar beam. This means that if you have very narrow beam width of the radar, then it is very easy to install the radar above the water because only small area directly beneath the sensor is being measured. However, if the radar beam width is wide, it is possible that there will be some other objects that the radar beam is going to be directed at, and then this will cause inaccuracies in radar measurement. I will show you some examples later. So when selecting a radar instrument for measuring water level, especially for measuring water level in an environment, then it is good to select an instrument with as narrow radar beam as possible. Positioning of the radar above the water is very important. The radar measures distance from the instrument to the water surface. If the radar is installed at an angle, like the picture on the right, the distance to the water will be greater than the actual distance that the radar should measure. The angle of the radar beam should be perpendicular to the water surface. Many sensors have internal tilt angle detector inside the instrument, so the sensor will report not only the measured distance but also its own tilt angle, so you will be able to position it correctly and to check if the radar is tilted. This is especially useful if you have the radar mounted on an arm and this arm is not firm enough, so over time the arm itself tilts. If the radar sensor measures its own tilt angle and reports it, you will know when the sensor is not positioned well anymore, and you will know when to send servicing team to the site to fix everything. As I already mentioned before, it is important that the radar beam hits only the water surface. It should not be directed at any other object, such as vegetation protruding from the water or some stones or other structures. If there is a clear situation, like the image on the left, the radar will accurately measure the distance to the water surface. However, if there are some other objects which are beneath the radar sensor, the radar beam will reflect not only from the water surface, but also from other objects such as stones, vegetation, and so on. And then, depending on the amount of radar energy reflecting back, the radar will measure distance either to the water level or to the top of the stone or to the top of the vegetation and so on. So this will greatly reduce the accuracy of the radar measurement. When placing the radar, you should really make sure that the area beneath the sensor, which corresponds to radar beam width, is not obstructed by anything, and it contains only water. There is also an effect of scattering. When the water surface is flat, most of radar energy is transmitted back to the radar sensor. In case of scattering, which happens when the surface is rough, if there are some waves on the surface, a lot of radar energy will be reflected away from the sensor, and only a small part of the energy will reflect back to the radar. Some industrial radar sensors, which are built for use in tank level metering and so on, which do not have the scattering effect, will not properly operate under conditions such as on the right image. So when you select the radar sensor for using environmental monitoring, make sure that you pick one which can handle scattering and adjust to the scattering effect so that you get consistent and accurate readings all the time. This should be completely avoided. So if there is some waterfall, you should not install the radar above it, because the radar will see both the upper and the lower part of the river. If there is a waterfall, you need to decide whether you need to measure the water level on the upper side or on the lower side of the waterfall and install the radar appropriately. It should be moved away from the part of the cascade or the waterfall so that no part of radar beam is directed to the other side of the cascade. It should only be directed to that side of the cascade where you intend to measure the water level. Many radar level sensors have the ability to configure the active zone. For example, if you purchase the radar, they can measure the distance to the water from ½ meter to 15 meters. It will measure the distance within the whole range. However, using active zone settings or active zone configuration, it is possible to reduce the active zone. So if you know that the lowest part of the channel is 5 meters away from the sensor, and if you know that the water will never rise more than 2 meters, you should set the active zone appropriately. So even if there are some temporary obstacles outside of the active zone, the radar will simply ignore them. For example, if there are some animals like birds that intend to fly beneath the sensor and so on, by correctly configuring the active zone, you will reduce the number of wrong readings caused by other obstacles or other objects that are temporarily blocking the radar beam. And just to end this short webinar, I will show several other pictures of installations of the radar sensor above the rivers and channels. On the image on the left, you can see that the channel is very narrow and there is a lot of vegetation on the channel sides. For this reason, we have extended the radar sensor approximately 1 meter away from the bridge side or from the bridge railing to make sure that it is positioned directly above the deepest part of the channel and away from all the vegetation on the side. The radar needs to be positioned above the deepest part of the sensor because when the water level is extremely low, it will flow through the deepest parts of the sensor. If the radar is not above the deepest part of the sensor, when that part of the channel bed is dry, the radar will measure just the distance to the channel bed, to the river bed, not to the actual water. So again, the radar sensor should always be installed above the deepest part of the river. On the picture on the right, there was no need to extend the radar away from the bridge. It was just installed directly next to the bridge railing. This also made the installation much more simpler and easier. On this picture, you can see one stone which protrudes from the water surface beneath, close to the sensor, but away from it. So we have moved the sensor away from the stone that protrudes from the water to make sure that when the river level is low, that we do not measure the distance from the sensor to the stone, instead the distance from the sensor to the water. This can also be tricky because if you install the radar sensor when the water level is high, you might not observe this type of stones that protrude the water surface during low water levels. So for this reason, it is recommended to install the sensors during low water levels just to make sure that the radar sensor is positioned correctly. If you have any other questions, please contact me at nixaorlik@geolux.hr. I or my colleagues will get back to you with any other information that you need about using radars for water level measurement. Thank you.